How to build custom layers in PyTorch, a practical guide. Discover how to create and integrate custom layers into your PyTorch models, optimizing them for specific tasks and enhancing your neural network architectures.
Have you ever wondered how top tech companies create AI models that are so unique and efficient? The secret lies in custom layers. Today, we'll unlock the power of building custom layers in PyTorch, empowering you to tailor neural network architectures to meet specific needs. Whether you're optimizing for speed, accuracy, or innovative functionality, custom layers are your toolkit. Stay tuned as we uncover how to define, integrate, and optimize these custom components, complete with real-world applications and detailed code walkthroughs.
PyTorch's neural networks are built on the foundation of nn.Module, a flexible and powerful class that allows you to define your own layers. In this segment, we'll dive into the heart of PyTorch, exploring how nn.Module serves as the backbone for creating custom layers. By understanding how to inherit from nn.Module, you can define initialization parameters and leverage its built-in functions, providing you with the tools to craft your unique layers. This knowledge is crucial for anyone looking to push the boundaries of what's possible with neural networks. Defining the forward and backward methods is where the magic happens in custom layers. These methods dictate how data flows through your layer and how gradients are computed during backpropagation. In this section, we'll break down the implementation of these methods, ensuring your layers function correctly and efficiently. We'll also discuss common pitfalls and how to avoid them, as well as performance considerations to keep in mind. By mastering these techniques, you'll be able to create layers that are not only functional but also optimized for your specific tasks.
Once you've created your custom layers, the next step is integrating them into existing models. This process can be seamless if done correctly, allowing you to enhance your model's performance and capabilities. In this block, we'll explore techniques for ensuring layer compatibility and how to effectively test and validate your integrations. We'll also look at real-world examples of custom layer integration, giving you the confidence to apply these skills in your own projects. By the end of this segment, you'll be able to take any model and tailor it to your specifications. Debugging and testing are integral parts of developing custom layers. In this section, we'll address the most common issues you might encounter and how to effectively troubleshoot them. We'll delve into testing strategies that ensure your layers perform as expected, utilizing PyTorch's built-in tools for comprehensive testing. By adopting an iterative debugging process, you can refine your layers for robust performance. This segment is packed with practical tips and strategies to enhance your debugging skills, ensuring your custom layers are both reliable and effective. Optimization is key to maximizing the efficiency of your custom layers. This segment focuses on identifying performance bottlenecks and techniques for optimization. We'll discuss how to balance speed and accuracy, ensuring your layers perform optimally in real-world scenarios. Additionally, we'll explore how to utilize hardware acceleration to further enhance performance. By the end of this section, you'll have a toolkit of strategies to optimize your custom layers, making them more efficient and suitable for production-level applications.
Custom layers have a wide array of applications across various industries. In this segment, we'll explore real-world use cases where custom layers have significantly enhanced AI capabilities. From innovative model designs in autonomous vehicles to specialized applications in healthcare, custom layers are driving advancements in technology. We'll discuss how these layers are being used today and what the future holds for this exciting area of AI development. By understanding these applications, you'll be inspired to implement custom layers in your own projects, pushing the boundaries of what's possible. Now that we've covered the theory, it's time to get our hands dirty with a practical code walkthrough. In this segment, we'll guide you through the process of building a simple custom layer in PyTorch, step by step. You'll learn how to implement a basic layer, understand the code structure, and tackle common coding challenges. This hands-on experience is designed to reinforce your learning and give you the confidence to create your own custom layers. By the end of this block, you'll have a working example to use as a foundation for more complex projects. Even the most experienced developers encounter pitfalls when working with custom layers. In this segment, we'll highlight common mistakes and how to avoid them, providing proactive troubleshooting tips to help you navigate challenges effectively. We'll also discuss how to leverage community resources and insights from experienced developers to improve your skills. By learning from past errors and adopting best practices, you can refine your approach and enhance your custom layer development process. This block is essential for anyone looking to minimize errors and maximize success.
As we wrap up this practical guide on building custom layers in PyTorch, let's recap what we've learned. You've gained insights into creating, integrating, and optimizing custom layers, and explored their real-world applications. Now, it's time to experiment and apply these skills to your own projects. We invite you to join the vibrant PyTorch community, share your experiences, and continue learning together. Don't forget to leave your feedback and suggestions in the comments, and subscribe for more content on cutting-edge AI techniques. Until next time, happy coding!